Let's look at this fifth generation communication, or fifth generation technologies that are used for networks. First, let's look at what is 5G, what are the issues, the challenges, and what is its effect on communication, also on health and other issues that are being discussed in many occasions. First, what's the generation? And the communication that started a while back in the 80s and 90s with mobile phones and wireless communication. So the generation here refers to the wireless generation or mobile phones and communication on networks. And the first wireless phone started as an analog phone that required a huge device, big device, needs to be brought around that has its transmitter and receiver. And then it was reduced in size from analog to digital. So when it was digitized, and it was digitized first, it had very little digital kind of functionality other than the actual communication. That was around the 90s. Around the 80s when mobile phones started, and the 90s when they were digitized and reduced tremendously in size. But they had very, very little functionality other than the actual communication and very, very basic text kind of messaging. And then each of those generations just increased the speed, increased the dimension, increased the range of the mobile phones. Third generation started introducing the internet and the actual pictures and videoing and functionalities. 4G increased the range again and the speed. It increased the broadband basically that the multimedia and the videos required in the 3G. The 3G was extremely slow, but they had the foundation, like the mobile phone is turning to be a computer more or less, with its memory, its storage, its graphics, sound systems and all that. 4G improved the performance by providing the speed of delivery, the broadband. And here we go, we're starting with that fifth generation. That started maybe last year in some countries. It still has very limited distribution, but it's on the spreading pretty fast around the world. So what does fifth generation offers? It offers tremendous speed, tremendous capacity, and therefore low delay or low latency. So it's just another improvement of the actual communication, but this improvement is huge this time. Every time improvement gets bigger and bigger. And research has already started in the sixth generation. So there's already sixth generation researchers are working. Always the next generation is there's no new inventions as such, it's just an improvement of technologies that already exist, or maybe increasing ranges or improvement in speed and all that. So first generation was analog and phone calls only. Obviously it's a mobile phone. Second generation converted to digital phone calls and digital messages. Third generation with data, and the fourth generation got into the internet and internet protocol services. So this is from distance-wise. How many devices. Operators in the downlink. It's the amount of number of devices that are increasing all the time with the generation. In the fifth generation compared with the fourth generation, amount of data that can be transferred is increased 1,000 times fold. So you can increase a lot, you can send a lot more data, 1,000 times more. The number of connected devices that you can connect can be increased from 10 times to 100 times, but you can have a lot more mobile phones connected within a square kilometer than you did with fourth generation. The latency can be reduced 5 times more, so the delay is reduced 5-fold. The data rate is increased, the speed at which data can be transferred, not the quantity of data, but the speed that can be read. And the battery life is increased also 10 times fold. So everything in the fifth generation is tremendous improvement. And especially the data, the amount of data that can be transferred, 1,000 times more, huge amount. So they're here again that the kind of values we are talking about, latency is 1 millisecond latency. Throughput, the amount of data you can transfer, 10 gigabits per second per connection, and you can have hundreds or thousands of connections. So this is 100 times improvement from before. Number of connections is improved also 100 times. You can have 1 million connections per square kilometer. That's a huge amount of connectivity that can be made. 500 kilometers an hour can be also mobility. You know, it's always a problem communicating on a moving device, but you can up to 500 kilometers, no problem now. And network architecture is pretty much an improvement to previous and based on previous technologies, but we'll see what makes this tremendous improvement. So we'll look later on at more detailed views. 5G or fifth generation will provide backward compatibility with the fourth generation, so devices that work on floor, they will still be able to gain some of the advantages of the fifth generation. Obviously, it's very difficult to make a complete and change over from one generation to another. So it's most of the changes, they will be gradual. Fifth generation will integrate with the fourth generation. At the moment, fourth generation usually you have antennas on masts that broadcast the area into a larger area. Fifth generation is not as much, the range is not as big for any of the antennas. The range of the antennas, there'll be a lot more antennas that transfer a lot more data, but at much shorter ranges. But they will be using the older technology, except kind of maybe multiplying it. Instead of having a single antenna, there'll be an array of antennas that will be transferring. The newer technologies, antennas generally used to broadcast in kind of not uncontrolled way, but in a larger area. Now they can actually direct. They can have directional antennas that they've used you can actually transfer data to a certain, using the same antenna without moving parts, without rotating antennas. You can actually change directions, and you can also change directions vertically. So you can provide a lot more either directed antennas, and that reduces noise and concentrate maybe the signal onto a particular device. They can actually hum in onto an individual device. Phones also send data, so they can actually measure the signal coming from a phone, and they can basically judge how far it is, and they can hum into it and maybe get the information to the phone at much clearer rate than before. The spectrum, or the amount of data that can be sent, or the amount of frequencies, it just adds them all up and uses as much as possible of all the different antennas, all the different devices. The architecture, within reason, it's similar to previous architectures, but the devices that are used, the technologies, are slightly different and they are improved. And the air interface is improved a lot. It's the most of the improvement comes in the antennas and the way antennas operate, capabilities of antennas, and the frequencies that are used that were not used before. There are 3 bands that have been identified for harmonization and launch of 5G in Europe. So there are certain bands of the radio frequencies in different countries that are not used, have not been used, by mobile phones for so many different reasons. They're not the most suited for mobile phones so far, or they're extremely high frequencies that don't have the range, they cannot go too far. But there are a number of these frequencies have not been used generally in Europe, but around the world there's always, in every country, there's certain range of frequencies that when used, that now they decided, okay, well, let's go ahead and use it. Usually high range frequencies. So millimeter waves, but the 5th generation, in order to operate using the 5th generation, they went down to millimeter waves. It's very short length waves. Devices are slightly more complex. They use different parts of the transmitted signal. Every wireless signal, it tends to have 2 aspects of it, the electric field and the magnetic field. They started using both of them when it was only part of that signal was used. Multiple transmission. So instead of having one single transmitter transmitting, you have multiple transmitters at the same antenna. And beam steering, when you send a radio signal to a mobile phone, wireless signal, it can be steered to a different location. And also beam shaping, where you can actually change the shape of the beam as well. So this, we'll see how later on this can improve performance, increase the number of devices that can be reached, reduce noise, and much more, a lot more advantages. And advanced modeling techniques, we'll look at some of those techniques that were used. So is a technique that increased the delivery of data, or the signals that can be sent, and is known as MIMO, massive input, or multiple input and multiple output, or massive input, massive output. So instead of having one antenna that transmits in a particular direction, first it transmits in multiple directions, and then multiple levels as well. And we'll see later on, when you have multiple signals that you can transmit, you can actually stir them without moving the antennas. So they can target different locations quite easily by sending the aerials, or the signals, at certain speed, one before the other, just like having light beams. You switch one light after the other, you think that it appears that the lights are moving, but pretty much it seems to work on wireless as well. So as you keep transmitting at different speeds, one signal, one magnetic wave signal kind of stirs the other towards it to a certain direction. So they found many newer techniques into steering or steering the actual antennas or the signal itself without actually physically, mechanically moving the antenna. And that can be done a lot faster and a lot better and a lot more precise. So fifth generation will provide an order of magnitude improvements in virtually universal. So it's kind of common around the world. The techniques or technologies can easily be made available, and they're all their kind of improved techniques. It will provide more capacity. It will provide a lot higher bandwidth availability, lower latency, so a lot less delays, and more mobility. So it allows more mobile devices within a square kilometer. This is actually suited. It's not just suitability. This is more out of requirement. It's tremendous. The plan is that the requirement for mobile communication has been increasing for the last 20 years or so, or 30 years. And they expect in the next 20 years or so, the amount of mobile communication will be so much required. In fact, with the self-driven cars, they will require so much communication with every traffic light, with every central device, with different roads, with it. And in factories, newer factories, every machine is already like its own. It has its own computer and communicates with other machines around the place. Like maybe a tractor is moving or a forklift is moving in a factory, delivering some data. It's moving to another location. They're all going to be communicating together. And so the amount of communication seems to be required in a huge demand. And in order to do that, there's just existing communication technologies will not be able to provide that amount of requirement. Like the number like at the moment, the fourth generation has a limit of how many mobile phones you can have within 1 square kilometer. If the number increases, the service will drop, the quality will drop tremendously. Not so with the fifth generation. It just provided a lot more. You can transfer a lot more signals to a lot more phones, and you can target them specifically to improve quality and reduce noise and all that, and interference. So there will be a lot more mobile device kind of availability. Connections for individuals, users, and connected objects will improve. Greater distribution of computing and storage. So everything will be, can be provided through just by providing increased communication and increased reliability and availability. Fifth generation devices must comply with safety standards, and there's where there's a lot of but every time there's a new generation comes out of mobile communication, there's always security concern. Well, not security, health concern. Many people believe that having these antennas could actually be tremendously harmful to humans, plants, environment, and birds and things like that. Nobody really has come up with tremendous, proof. So right now, there's very few weak kind of researches that were done. Maybe it is harmful, but there is no proof as such. And I'm almost certain if it was harmful, there would have been good proof by now. There isn't. But it's like you know, smoking is bad for you. It started back in the 40s and 50s, you know, this huge amount of smoking, and people were going saying harmful, and it took maybe 20 years, 30 years before they realized, oh yeah, now there is a strong relationship between cigarettes and lung cancer or something like that. But with mobile phones, you know, there are simple experiments or simple small research, isolated research, but there isn't really one common, and I'm almost certain at this stage, if there was, they would have been available, because many governments have carried out specific research. Many individual companies and doctors or people who are interested in this area, they would have found something by now. Maybe there is, maybe there isn't. But certainly it's not a good idea to expose yourself to, you know, to a device that radiates, that sends electromagnetic signal. But the medical, in general, and also medical departments in governments, they've actually found no real danger as such from mobile phones. And mobile phones are getting better and better. Fifth generation, the other good thing about fifth generation, it's yes, there is more communication, more radiation as such, but the levels are much smaller, because fifth generation is very short distance. It doesn't cover long distances, only covers very short distances. And therefore, and the strength of the signal is not as powerful as with fourth or third generation. So the power of the signal has been reduced, but there's more of it. Whether that proves in the future to be more harmful or more safer, the idea now that it is safer actually to reduce the high level. But there's a lot more of it. So some people say, yeah, a lot more of lower radiation may be harmful. So, but it's not really proven. So, very efficient electromagnetic force levels in public areas will be well below the safety standards. So with fifth generation, the actual standard is with the fifth generation, there's lower level than there was with fourth generation. The strength of the signal, the level of the EMF, the emission kind of magnetic force is going to be, the way they measure it is going to be a lot smaller than before. Environment of EMF levels may increase slightly near to sites with the addition of the fifth generation. There'll be the amount of data, like in a factory, there'll be a lot of communication between different devices. But actual levels under investigation with results to date showing levels well below. So in general, it seems to be slightly safer actually than fourth generation. But there are many people going around, you know, they just, you know, looking at fifth generation. Anytime they find, especially in the UK and other places where they find a company installing 5G antennas, they kind of interfere and stop them, but there is no real legal or, you know, official site or government that says, hey, stop installing them. In fact, governments are more going for more fifth generation communication. They will solve a lot of issues. They will provide a lot of communication requirements for many companies, businesses, and individuals. So why? Because in summarizing fifth generation, it will allow more devices to be connected, right? In hundreds of thousands more data to be transferred. It will definitely, because the way the antenna technologies has improved, there will be a lot more data being transferred around, and data transfer rates, speed-wise, will also be faster, and there'll be less delays, less cost. It's going to be a lot cheaper, and less interference. So I mean, it looks like, you know, looks like somebody's advertising for this stuff, which we are not. But so is there going to be more security? Well, security is through encryption, maybe, yeah, but encryption is not a cheap thing. It requires a lot of processing, so that's fine. You know, this provides more processing, more data transfer, more environment friendly. Okay, we'll leave that question because we don't know. You know, maybe in 20 years it'll prove, yeah, it had no problem, it was even better. Or maybe there's some harmful signs will appear and we'll know that it wasn't, let's say, more efficient in service creation time, yeah, and more efficient at hardware flexibility. We'll see about hardware. Main applications for 5G, where is it going to be used, where it might be needed more. Mobile phone communication definitely will utilize that. Smart homes, like the next 20 years, there'll be tremendous increase in the devices at home that will require to be operated either remotely through the internet or from other locations. Smart cities, definitely, this is gonna always only increase between communication, between police forces, between trains and cars being moved around, controlling traffic in different areas. It's huge, even taking care of noise and environment. And manufacturers, also another application where fifth generation will be tremendously helpful. And the good thing about fifth generation, like its range is not that big, so you can have in one area, concentrated area, you can have thousands of devices. They'll have no effect on the another area up the road, or maybe, you know, a few 100 yards away or so. Self-driving cars definitely is big user, going to be big user of fifth generation. With self-driving cars, they will have to be able to transmit signals and receive signals from cars around them. And so all cars driving, they'll be sending signals to one another, so that they have to be able to communicate. They'll also be receiving signals from traffic lights, bridges, emergency services, other things directed by, you know, blocking roads being blocked. Smart societies and smart electric grid as well. So there's huge use for each one of those here. So it's more likely that in a city, these are again just mentioning smart driving, traffic kind of control environment, health environment. There's so many applications that will be using controlling the electric supply or electric grids, or controlling the energy in general. Homes are connected and might, you know, maybe starting heating, talking to your fridge, getting, you know, all washing machines, things like that. This is going to be tremendously controlled, digitally controlled, and therefore computerized, and require a lot of communication. So the number of users is not just in the old days. 30 years ago or so, there was one phone in the house and everybody used it. Then now suddenly everybody has a mobile phone. Then in 10 years' time, the fridge will need its own connection, the washing machine, its own connection, the TV, every device in the house will probably require its own connection and its own communication with other devices and management and access and things like that. Beamforming is another important aspect, and that's what we'll be concentrating on later on. We'll look at how beams, how antennas work. That's really the main part of this. This is just an introduction in general to fifth generation. But we will be looking at how do antennas work, and how do they actually form the beam, and how do they direct a beam to a certain location, and what's the point of directing these beams. So with newer antennas, they'll be able to horizontally spread the beam around and also vertically communicate. So they can communicate with individual devices. The older antennas, in the fourth generation antenna, it just broadcast. It's one broadcast to everybody. With the newer techniques, they're able now to direct each individual device, and therefore they can, the multiple antennas, So there are many different levels so in the same individual antenna, and each antenna, each device or each level can be also used to be steered. So that's what the fourth generation used to be like. One broadcast that covers everybody. Now, that broadcast will target each individual and you'll be able to reach individual devices. And that's known as beamforming. So we'll look at beamforming later on. So, again, there's just more applications. Parking cars, smart parking will require interacting with cars. Maybe there'll be, you just drive to a car park and leave your car and it'll drive itself. Obviously, you won't even need to drive it. But even parking will need to be interacting with the actual parking facilities. Smart mobility, smart wearable watches, water quality. It's huge. The amount of applications is unbelievable. There will be tremendous use for it. It's just, an image of what communication might be like just between cars on a motorway, where distances are maintained, where direction, where intentions of changing lane or something, a car might want to do it. So you need that kind of communication. You need a huge amount of communication to be available. Traffic lights will talk to cars to allow them to continue or stop or move around. All that form of communication would require, but luckily it's localized kind of within reason. It's not a huge communication, and it doesn't require a high level of intensity of the transmitted signals. This is some way or another way of showing the levels of improvements at certain levels. How many times is the improvement in particular cases in 5G or fifth generation? The user experience data rate, megabits per second, is 10 to 100 times improvement between the different generations. What's this connection density? How many devices will be able to connect in maybe a square kilometer? Network energy efficiency, 100% improvement. Mobility, how fast you can still drive and you can still have a successful communication. So there's tremendous improvement in almost each aspect of communication. So how is it possible to provide all this? All the improved, the increased number, the bigger, density, the clearer signals, the lower maybe power supply, and the lower noise and energy and noise in the signal. There's a new radio multiplexing technologies. So new technologies were used to multiplex multiple signals, and you can join a number of signals into a single beam. A new efficient spectrum usage techniques. In fact, a new spectrum was used completely. So there was a range that was not used before they started using it. But it's a high frequency, short ranging, short distances was used, and it was used successfully. New energy saving mechanisms. So we'll see, about those. The new spectrum, how is that done? Beamforming, changing the shape of the beam and the direction of the beam, simultaneous transmissions and receiving on the same frequency. So you can send and receive on the same frequency, but for example, I can transmit, in the older system, you transmit at one frequency, and only, everybody gets it. If you're not interested, you leave it. Now with the newer one, you can transfer one frequency to this, and then direct another signal, the same frequency, to another device, that there will be no interference between them. The fact that now antennas can direct different signals simultaneously in different directions reduces the interference and allows that, yeah, we can transfer same frequency to multiple users. Do not transmit a signal during idle communication. Okay, that's an antenna muting. Right, so these are some of the main kind of technologies that allowed fifth generation to be able to deliver what, the bigger ranges that's delivering at the moment. First, millimeter waves. That's very short radio signals. They were not used in the past. Small cells. So a group of devices or an antenna does not cover a larger area. It covers much smaller area. So that's in a way came up as an advantage, even though in the past it's better to maybe split your city into bigger areas. Now, because of the nature of the frequency that's used, you cannot send them long distance. They're going to be shorter distance, but turned out to be much better. So if you can have 1 million devices, small area, the next neighbor, they can have another 1 million instead of having 1 million in one big, huge area. Anyway, massive MIMO, that's the antennas themselves, the technique that they started transmitting. Instead of one antenna making one big transmission, you can have multiple antennas, and they started increasing them by like having 64 antennas, 128 antennas, and they work together. And actually they found when antennas work together, you can actually stir the signal in different directions, and you can send it at different levels. Beamforming, and finally, full duplex can be used where it was not possible before. Now this is the range of frequencies. Now, not all frequencies are available and are, usable. Some are very, very low waves or long wave signals, or very, very short ones. They are basically useless. But there's always more range that was not used before at high frequencies between around the 6 gigahertz and the 300 gigahertz was not really used a lot. Most of our communication in the past has been between the 3 and the 6 gigahertz. 6 to 300 gigahertz was considered not suitable, so they started using it. Unfortunately, it's not powerful enough to go through buildings, or if there are obstacles, they will actually affect the transmission. So other obstacles that can cause a reduction or noise, like trees, rain, things like that, can actually obstruct the transmission. The older generations used long waves that can travel a little bit longer. When devices are behind obstacles, you lose the actual coverage. You don't receive your contact or the actual signal, and you get cut off sometimes in areas where you might not have the cover. So with smaller cells, now they have smaller antennas or amplifiers or repeaters, but more antennas are available that will actually go around obstacles, and they can transfer the signals to devices that are behind other obstacles. So the newer generation, they have smaller cells, and each one has smaller ranges, but that can be used to reach devices that were maybe behind obstacles in the past. So smaller cells seem to provide, be able to get down to a lower level or more detailed level of access. The next one is MIMO. That's multiple inputs, multiple outputs. Again, in the past, we usually used to have one antenna that transmits and one receiver for each area, but the fifth generation decided to go for multiple antennas that transmit and multiple receivers. So the original probably would be one of those, but now with multiple of those, you can actually transmit a lot more. And each one of those here, it can be used to first to transmit the increase in the capacity, the amount of data to be transferred, but also it can be used for directing and forming the signals. Because if they all transmitted the way the older technology did, there'd be a huge amount of interference and they're all transmitting into each other's ways. So what they do is they go for beamforming, where you target individual devices by, instead of sending one signal around, first you concentrate it into a particular direction that increases the intensity of the signal to that particular device, improves reception, reduces noise, and reduces interference as well. Other devices, then they'll not all be getting the same signal. So every signal will be targeted to a particular device, and this is all done at tremendous speeds and automation and all that. So also, you can actually, again, in the past, the signals always kind of transmitted horizontally to a certain direction. So very high or very low receivers may not get the clearer signal. Now you can actually target them as well vertically, as well as horizontally. You know, you can spread them out and you can target individual devices, but you can also spread them vertically and direct your transmission to a particular level or particular height. So this is simultaneous supports elevation, beamforming, and continuous. So there's multiple and individual kind of devices can be supported at different levels. That's not all, but also at different buildings in a city where, for example, a building can block a form of communication. And what they found is that buildings also, as well as blocking a signal, they actually reflect signals. So you can get a signal if it hits a building and reflects, and you can actually measure it through a device, and you can actually transfer a signal, find out what direction it came from, how powerful it is, and with small calculation you can pinpoint the device. And you can actually send in the opposite direction a signal targeting that particular device. So very simply, you can actually, every time you receive a signal, that mobile phones, they also send signals to the antennas, and the antennas can measure out the direction and the strength of that signal. They can find out where it comes from and the strength, the direction, and they know how to actually target it back, the best way to target it back. And by targeting, you can actually reduce the interference between the signals. If you knew, sometimes you might direct a signal to a particular building that you know is going to be reflecting towards the particular device. Beamforming, the system traces the source, the direction, and the strength of each signal. So the antenna will, every time it receives signals from different mobile phones or sources, it can find out the direction, the strength of each signal. It identifies the positive and negative interference in that signal and introduces time delay to signals sent or received by different antennas. So it can actually, if you have multiple antennas, but they don't always transfer, so you can instruct some of the antennas to slow down, to stop while another one is transmitting and then stop. So spreading the different times or introduce some sort of delays between antennas. Find out the best direction and send signals to each device individually, and using signals bouncing off buildings and other obstacles, and this reduces noise, increases strength and the quality of the received signals. So this is used a lot in beamforming in the newer generation. Also, full duplex. It's always been a problem with wireless communication, is to have communication in both directions, or full duplex communication always cause what's known as collisions. So they have newer devices, high-speed switches that can actually receive the signal and just hold on to it for a millionth of a second, and while it allows one signal to go in one direction and then just storing it for a tiny bit of time, it gives the effect that you can actually have a smart switch that will allow communication to happen in both directions. So two signals coming to the switch, it will hold on to one of them and kind of more or less switch them around and keep them going in opposite directions without having, the collision. So there'll be a tiny short amount of delay, but it's manageable and it can be improved. Well, so that allows actually signals to be transferred in both directions. There are many international organizations that are kind of taking part in some sort of collaboration to get the 5th generation working worldwide around the world. And these are some of the international groups. There's the International Telecommunication Union, the EU, Germany, UK, US, they're all, China and Japan and Korea. Almost every country has some sort of work or collaboration or law. So there's so many of those companies and organizations that are working on 5G, and many are doing it for money, obviously, that's number one, and then technology improving and provision of so many services. Research is already, as I said, is going in the 6th generation. So just again, summarizing here, the benefits of 5th generation, 10 or 100 or 1,000 times more capacity. So 5th generation, what does 5th generation mean to users generally? More capacity. When we say 1,000 times more, that's a huge amount. Higher capacity and coverage, so you get bigger coverage even though the cells are smaller. The range is smaller, but you'll be able to transfer it a lot more. Low power consumption, less interference. Because of the beamforming, you can actually reduce interference and increase the strength of a signal that comes to a device. So instead of sending, remember the energy that you send out in a wireless network goes around in a circle in every direction. If you can concentrate it into one particular area, you get stronger signal that goes even longer, and it will reduce interference to other devices. And with multiple antennas, remember, it's nothing came out of space. They used to have those antennas, just now they have arrays of those antennas, and you can control them to produce, signals in a particular direction, directional signals, or form the shape of those signals to provide stronger signals where you want them, and less radiation towards where so it wouldn't cause noise. Low latency and high efficiency, so we're gonna, obviously we have higher speeds and more data to be delivered, and it addresses the diverse spectrum and services and supports multiple bandwidth and spectrum, provision of 1,000 times higher wireless capacity, area capacity, saving up to 90% of the energy per service provider, and service creation time cycle from 90 hours to 90 minutes. Secure, reliable, and dependable internet with a zero perceived downtime, maybe, hopefully, and facilitating very dense deployment of wireless communication links. That's really one of the main issues, that you can have a lot more communication links to connect over 7 trillion wireless devices serving over 7 billion people, hopefully. Once it's connected all over the world, ensuring for everyone and everywhere the access to a wider panel of services and applications. So, right, so then the next thing is the 6th generation. Is 5th generation enough? 5th generation provides more powerful virtual reality and augmented reality systems, interconnected smart cities, smart farms, smart factories, manufacturing cars and road vehicles, intelligent robotics, health services support, and a lot faster, less delays, and more connectivity. Why do we need, yes, 6th generation?
Yeah, for the 5th generation, we said low power consumption.
Say again?
For the 5th generation, you said one of the benefits is low power consumption.
Yeah.
So because I'm having multiple repeaters, I'm connecting more devices, I'm using more data, so how am I consuming low power?
Because for an individual device that's using the 3rd or 4th generation, your mobile phone needs to send a signal to an antenna somewhere that's a few hundred meters or away. With this one, with the 5th generation, the antenna has to be much closer. It's like maybe, I don't know, maybe no more than 30 meters to 100 meters is probably the maximum distance. So the energy you require to transfer your signal is going to be a lot less. There's going to be a lot more of it, but a lot less in intensity for an individual user. And consequently, this is where also the health-wise, they say it's probably healthier, because the signals that are transmitted by the transmitters are not as strong, because they don't need to go as far. Okay, so why are people still thinking about 6th generation? It's just because of the expected demand. 5G has latency of around 4 milliseconds, and in 6th generation, we may have virtually 0 latency. So delay-wise is almost 0. I can't remember now, but they have actual figures, and if you want to download a video, how long will it take? It'll probably take 1,000th of a second or something like that with the speed at the moment. So with the 5th generation speed. So speeds, there's always going to be demand, but definitely we're going to have more demands for more connections, more devices, more users, and eventually now maybe a car will be an entity. Maybe eventually even a car will require 5 or 10 different connections. Clear images where video communicating, you're going to have even clearer images. Major differences between 5G and 6G are speeds and latency. So of course now 6G is still under research. 5G has already been researched the last 10 years. They've been researching on it. And now they're kind of trying to get even bigger, faster, and less delay equipment. And they will be coming out in a few years, 5 years from now or 10 years, and they'll be the 6th generation. How much faster, we can only guess at this stage, and most likely it will use even higher, ultra higher frequencies. And similar to 5G, localization due to the low range of higher frequencies, the 6th generation will even have smaller ranges, maybe even down to 10 meters. So who knows, but at this stage, every generation reduces the range. So that makes it safer, but it makes it, the noise is limited to a smaller cell. So they are reckoning with 6th generation, they're going to be 10 meters is the range, the maximum range for that. That is far too short. and requires erecting thousands of towers in small areas. That's not obviously efficient when you get down to that level of 10 meters where you can see the antenna everywhere. Every building has a corner antenna. So I don't know how things are going to work out. So maybe new ways will be discovered to transmit higher frequency signals, but for longer distances. At the moment, higher frequencies don't go far. But there's plenty of them now that we cannot use, we have not been able to use, and we're not able to use. But with the fifth generation, went to a certain range and started using it. Is it safe? Okay, I don't know, right? At this stage, no, nobody knows, but it seems to be safe. Many governments would not allow it unless it is safe for people. Say here in Ireland, if in 10 years we realize, people started getting sick because of this fifth generation, they will be suing the government, the Department of Post and Telegraph and all that for allowing it to be in the country. They won't take that risk, especially politicians, so they won't. But there isn't one major research. There was one research I read about where, in one of the states, that women drove mobile phones, and you're not allowed to use your mobile phone while driving in many countries. But this particular town or city, when the research was done, that ladies were driving and they were putting the phone there on their chest, and talking. So legally, they're not breaking the law; they can still communicate. But then they noticed, according to the research, that there was higher breast cancer kind of levels of breast cancer in that city for that period of time that was used. I don't know how true that research is, and is it related only to that? It was not affirmed or confirmed later on. So there's nothing really absolutely safe. Some people say, a mobile phone, when it's always radiates. Mobile phones, by the way, always send signal every few seconds to the tower to let it know where it is. And if you're charging a mobile phone, if you put a mobile charger, you can actually, with an electromagnetic signal sensor, you can actually, if you bring your radio or something beside it, there'll be interference. There'll be interference about half a meter around the mobile phone at the moment. And they say some people say that's not safe. At least if you plug in your mobile phone in your charger, don't put it beside you or beside your head in bed, put it at least a meter away from you. That will be safer because it tends to start radiating a bit more. Is that radiation safe or not? Well, it can be healthy, but it may not be harmful or not very little harmful, the harm is very low level, but it's better not to deal with it. Some people say men always carry their mobile phones in their pockets, and that actually can affect their ability to reproduce children. So I don't know how truthful that is. So there are a lot of material that's not research proven, but we don't want to wait. Maybe that's one way of reducing the world population. But anyway, okay, so that's where the DNA can be affected by radiation. So how truthful that is, I don't know. So you can have a look at this and maybe research it. Right, let's go straight into antennas. So this is just a general kind of information about fifth generation.